find the derivative for arctangent and arccosine. So in this video, we're going to look at finding the derivatives of the inverses of the other four trigonometric functions. Alright, so those other four inverse functions we're going to have to take the derivative of are inverse tangent, inverse cotangent, inverse secant, and inverse cosecant. So the derivative of inverse tangent ends up being 1 over 1 plus the inside squared. Or in this case, tangent inverse of u, the derivative will be 1 over 1 plus u squared. And if we do have to use the chain rule, we do have to then multiply this by the derivative of the inside, or u prime. Then, to take the derivative of inverse cotangent of u, it's going to be very similar. Since this is a co-function, or a c in the front, it's just going to be the negative version of inverse tangent, which is negative 1 over 1 plus the inside squared. And if we do have to use the chain rule, it'll be then times u prime, or the derivative of u. Now, just like with sine and cosine, we do have restrictions on the inputs, because remember, u is the output of our tangent function. Or the range of our tangent function. And if we remember back to pre-calculus, the range of our tangent function is all real numbers, or from negative infinity to positive infinity. So this condition is also true for the derivative of the inverse tangent function. And similarly, the restrictions on u are all real numbers, because again, u is the output of cotangent, or the range of cotangent, which is also all real numbers. Moving on to inverse secant. Inverse secant of u is going to be 1 over the absolute value of u times the square root of u squared minus 1. And then if we do have to use the chain rule, times u prime. So this one is a little bit weird and awkward, and one that you will probably have to commit some time to memorizing, because it's not quite as easy as the other ones. However, if we do want to look at the derivative of inverse cosine, because it has the co at the beginning, we know it's just going to be the negative version. So therefore, the derivative of inverse cosecant is going to be negative 1 over the absolute value of u times the square root of u squared minus 1, and again, times the derivative of the inside if we have to use the chain rule. So really, to memorize these four inverse trig functions, we really just have to memorize 2, and remember the co-version gets the negative sign. Now when it comes to restrictions, again, because u represents the output, or the range of secant, that means that our inside has to be greater than the absolute value of u, and same thing for inverse cosecant, since this does represent the output of cosecant. We know the range of cosecant is also going to be absolute value of u is greater than 1. And again, just like with sine and inverse cosine, these restrictions are important to know if you're moving on to Calc 2 or higher level maths. They're not really going to play a part in Calc 1, because again, we're just learning how to use these formulas, and calculus is really more of an introduction course than an upper level math class. So again, important to note, but not really important to remember for this course. So let's dive in. So here we want to find the derivative of the following. We want to find the derivative of arctangent of 4x. And let's remember from pre-calculus, arctangent is just another way of saying tangent inverse. So we know we're going to have to use the tangent inverse formula here. But before we do that, let's take care of a little bit of side work. So we know that the derivative of inverse tangent, or in this case, arctangent of u, is going to be 1 over 1 plus u squared times u prime, because don't forget that chain rule. So the first thing we have to do is we have to identify what our u value is, or what is the function inside of arctangent, and we can see that that's going to be 4x. So therefore, we're going to set our u equal to be 4x, which makes our u prime just 4. And now that we have all these things set up, we can go ahead and take the derivative. So the derivative of arctangent is going to be 1 over 1 plus the inside squared. And we said the inside, or u, is going to be 4x times the derivative of the inside, which we said was 4. And now we just have to simplify a little bit. We know that when we multiply a fraction by a whole number, that whole number just gets multiplied to the numerator. So that's going to leave us with 4 over 1 plus. And then we have 4x quantity squared. Well, 4x quantity squared means we're going to take 4x and multiply it by itself, which is 4x. And 4x times 4x is going to be 16x squared. And there we go, that is simplified. So therefore the derivative of arctangent of 4x is 4 over 1 plus 16x squared. All right, next up we're being asked to find the derivative of secant inverse of 2x. So again, let's just come over here and let's just do a little side work. We know the derivative of secant inverse of u is going to be 1 over the absolute value of u times the square root of u squared minus 1, and then don't forget that chain rule times u prime. So, just like before, we need to figure out what our inside function is, or what function is inside of secant squared, and that is 2x. So u will be 2x. Well, we do have to take the derivative of this, and the derivative of 2x is just going to be 2, so we know that u prime will be 2. Well, now that we have that taken care of, let's take the derivative and substitute everything in. So we're going to have 1 over the absolute value of the inside, which we said was 2x, and that's times the square root of the inside squared minus 1, and we said the inside was 2x, and then we have to multiply by the derivative of the inside, which we said was 2. All right, now it's just time to simplify and move on. We'll take the whole number, we'll multiply it to the numerator. I said we'll multiply it to the numerator. Wow, don't really know what happened there. Leaky pen? I don't know. But again, we want to take the 2 and multiply it to the numerator. And then let's see, that's going to give us 2 over the absolute value of 2x times the square root. And then we have to do 2x squared, which is going to become 4x squared, and then minus 1. And then that is our derivative. If we really wanted to be fancy, which, I mean, we do, come on, let's show off a little bit, we could take this a couple more steps further. Because we're going to leave the top as 2, but this absolute value of 2x in the denominator, well, I can rewrite that as being the absolute value of 2 times the absolute value of x times the square root of 4x squared minus 1. All right, cool. How does that really help us? Well, the absolute value of 2 is just going to be 2. So therefore, we're going to get 2 times the absolute value of x times the square root of 4x squared minus 1. And this gives us a factor of 2 in the numerator, a factor of 2 in the denominator, so those will cancel out, giving us a simplified version of 1 over the absolute value of x times the square root of 4x squared minus 1. And again, this final answer is just me showing off a little bit, and if you want to show off, you can do that too. However, Newton should accept this first answer a-okay, no problems. All right, our next example, we want to find the derivative of arcsecant of x to the 5th. Now, since our whole goal is to kind of do everything in kind of one step, we don't want to do that side work. We want to do all that side work in our head so that we don't have to waste our precious time writing that out. So we're going to try that here. So first off, we want to identify the inner function, and we can see that that's going to be x to the 5th. So when we take the derivative, we know the derivative of arcsecant, or secant inverse, is going to be 1 over the absolute value of the inside, which is x to the 5th, times the square root of the inside, x to the 5th squared, minus 1, and then times the derivative of x to the 5th, which is 5x to the 4th. As you can see, once we get to this stage, it's going to save us a lot of work. But continue to do that side work, continue to use those training wheels as long as you need to. Just know that the final goal is to not have to use them. Then from here we can take the 5 times x to the 4th, we can multiply it to the numerator, and that is going to leave us with a derivative of 5x to the 4th all over the absolute value of x to the 5th times the square root, and x to the 5th squared is x to the 10th, because when we have the power of a power, we want to multiply the exponents, and then minus 1. Boom, 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 derivative. And finally, our last example, we want to take the derivative of 4x cubed times arccotangent of x. And oh boy, this one's going to be so much fun because we have to use the product rule, because we have 4x cubed times arccotangent of x. So therefore, the 4x cubed is going to be our first function, and the arccotangent of x is going to be our second function. So when we take the derivative, product rule says we take the derivative of the first term first, which will be 12x squared. We will leave the second term alone, arccotangent of x, always, 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 plus, times the untouched first function, 4x cubed, times the derivative of our second function. Now to take the derivative of the second function, let's remember our cotangent is just another way of writing cotangent inverse. And if we remember, the formula for our cotangent is negative 1 over 1 plus the inside squared times the derivative of the inside. So again, let's just write that over here so we can see that. Arc cotangent of u is negative 1 over 1 plus u squared times u prime. And we can see in our problem, our u is going to be x. So we can substitute that in 1 over 1, excuse me, ooh, what happened there? Negative 1 over 1 plus our inside, which is x squared, times the derivative of our inside, which is 1. And now it's time to simplify. There's not a lot we can simplify at the first term other than dropping the parentheses. Plus. Well, then we can take the 4x cubed times by the negative and times it by the 1, which means we no longer want that plus sign in between our terms. That is going to become a minus sign. So we can get minus 4x cubed times 1 over 1 plus x squared. Almost done, because then we can take the 4x cubed and multiply it to the numerator, giving us a final answer of 12x squared arc cotangent of x minus 4x cubed over 1 plus x squared as our final derivative. And that is it, folks. That is finding the derivative of arctangent or arccotangent functions.